Okay, hi guys. We're gonna do problem number 3.
Yay!
Yeah. In the back of the blue worksheet, it's gonna be great. Okay, so we're talking about a 17-foot ladder, and it's sliding down a slightly greased wall. Okay, which is great. So if I'm right here, and I've got this 17-foot ladder right here, and it's falling down this way, the bottom is naturally gonna go out that way, right? So we need to call these. You guys got some letters you want to use for these?
B.
B? B for base? How far the ladder is away from the ground? Why is 17 such a nice number? Does anybody know why I picked 17?
It's one of those triples.
It's one of those triples. Maybe 8, 15, 17 would come into our problem later, which is a good thing to keep in mind. 17-foot ladder is sliding down a slightly greased wall. Slightly greased wall. If the top of the ladder is falling at a rate, ooh, I need a letter for this.
W.
H.
Wall.
Wall.
Just do H.
Can I use H for height? Okay. H. Isn't DH dt, didn't I tell you how fast it was sliding down the wall?
No.
3 feet per second. So DH dt is -3. Why is it negative?
We're going down.
Going down. And this distance is getting smaller. Good. But then, if the top of the ladder is falling at a rate of 3 feet per second, at the moment when the base of the ladder is 8 feet from the wall, how fast is the? Okay. So at that single moment when it's 8 feet from the base of the wall, we have an 8. There's our 8, 15, 17. But it's only 8 and 15 for a split second, right? Now let's do that thing we did with the rectangle. If this ladder is like against the wall and then sliding and then sliding and then sliding and then falling on the ground, my area of my triangle, what's it doing? What's my triangle area doing?
Getting bigger than smaller.
Getting bigger than getting smaller, okay? So if I'm at the 815 part, it's like, I guess it might be the, can you picture when it would be the biggest, when the area of the triangle would be the biggest?
When it's 90, 45, 45,
Yeah, maybe when it's a 45, 45, 90. Maybe like it's like, ooh, and right when it's like right in the middle, like the 45 might be the biggest. Okay, what am I asking for? Oh, how fast is the base of the ladder moving away from the wall? All right, so I want to find out what is dB dt when B is 8. Okay, so first thing we need an equation that relates B and H and 17. B and H and 17.
X squared plus Y squared equals 17.
Yeah, okay, I'm going to use these letters. B squared plus H squared equals 17. Now the cool thing about this is like the ones we did on the other side, all we got to do is take the derivative of the whole thing with respect to t. None of these letters in here are t, right? None of these letters are t. So every single one of them, if I do chain rule, I should multiply dd dt or dB dt or dH dt or whatever it is. Okay. So here we go. We just got to do it. My derivative of something squared
2b something.
Times the derivative of something.
times the derivative of something. Okay, I hope the red shows
Why
up
did you
okay.
change your notation in how you teach
What
today?
do you mean?
Like you went from saying b prime to db dt.
No, I said I don't want you to say b prime.
Yeah, but that was okay until today.
Because it was always just like y.
Okay.
The only one I ever did was like y. Yeah, that's a good question. And some people do b prime. It's okay. I just like seeing that it's in terms of t, so I leave it. Derivative of h squared is 2h dh dt. It's, you know, it's kind of, I mean, if you want to use h prime and b prime, it's okay. It works. You're just like solving for the right one. I guess I just like the emphasis that it's always with respect to time. Uh-oh. What's the rate of change of the length of the ladder? 0. Some people say, ooh, I want to call this like L for ladder. And then the derivative of L squared is 2L dL dt. But what's dL dt? 0, because it doesn't, the ladder length doesn't change. So we just use it a number because it's a number. Okay. All right. So the rate of change of the number is 0. Oh, and now all I gotta do is plug stuff in.
X squared and Yeah. 17.
Oh, I did. Okay.
Now
Good.
that I've
Thank
done
you.
it.
So now I'm just going to plug stuff in. If you feel like canceling out the 2's, that's fine. Something you always want to do too is check to make sure that the thing you're solving for is the only thing that you don't have. Because I'm looking for dB dt when B is 8. I'm thinking that dB dt should be a positive number, right? Isn't this getting bigger? All right, so let's plug in. What's B at that moment? still going. What's B at that moment? 8. dB/dt at that moment, I don't know. H at that moment?
15.
15. The HDT at that moment, I do know it's -3. And now I'm going to solve for it. So I've got 16 dB/dTs. I've got minus 45. No, 90. So it looks like dB/dt is whatever 96 16s, 45 eighths, 45 eighths, 45 eighths, 45 eighths. What are my units? Feet per second. So we've got a little bit bigger, a little bit more than we're like 7. What is that? 5 and a bit. 5 and 5/8. Okay. 45 feet for every 8 seconds. That's kind of cool too. Okay. How long is that? How long is that, Sarah?
Like 6 minutes.
Should we pause it and do part B and C as
Yeah.
different videos?
Yes.
People like watch part A. Okay, part A.